So there are two main types of waves, all right? Two types of waves. And I will encourage you to go ahead and write these down right now. The first type of wave is called a transverse wave. Transverse wave. The second type is called a longitudinal wave. Now, what exactly do these words mean? What does transverse mean, and what does longitudinal mean? So we will start with a transverse wave. Transverse wave. A transverse wave is a wave in which the particles are moving, the particles are oscillating, is the word for this, oscillating in a direction that is perpendicular to the direction of the wave movement. Okay, so go ahead and pause this video, write that definition down into your notebook or your handout. All right, and this is kind of a confusing definition, right? So we need to break it down a little bit. We need to figure out what do we mean by oscillating and what do we mean by perpendicular. And to do that, I will show you a quick video. Here is a human being, let's call her Jane. She is creating this rope wave, and she has very conveniently singled out one particular part of the rope, this red bit. And so this is a particle. And what she's going to show us is that the movement of this particle is going to be perpendicular. Perpendicular simply means at right angles. So that means that this wave is going to be going in this direction, that direction, all right? But this specific particle and all the other particles or parts of this rope are going to be going up and down, all right? So while the wave is going from, in your case, it would be, I guess, from left to right, the individual particles are going up and down. And remember, this is a transverse wave. So as you can see, this particle is going up and down, but the wave is traveling from her hand in that direction. But the particle itself is just going up and down, all right? And so the way to remember what a transverse wave means is to remember that the word transform means to change, right? It means to become different. So with a transverse wave, the particle is moving in a direction that is different from the direction in which the wave is moving, all right? The particles are moving in a way that is different from the direction in which the waves are moving. And transverse waves, when drawn, will always look like this. Right? They'll look like this. And most of the waves that you're going to look at in this unit and in the next unit are transverse waves. The next kind of wave that you need to know about is a longitudinal wave. Longitudinal wave. All right. In this case, the individual particles are moving in the same direction as the direction of the wave. All right. And a perfect example of this, let me write that definition very quickly for you. Particles moving in the same direction of the wave. Same direction of the wave. All right. Now, a perfect example of this is a wave you can make with a slinky. All right, and I'm going to go ahead and play this video for you. All right. And so if you notice, fixate your eyes on this red part of the slinky. You can notice it's going back and forth, forward and back. And that's the same direction that the wave is going. And the wave is going this way, and the individual particles or parts of this slinky are also going in the same direction. All right. You will usually draw a longitudinal wave like this. You will show an area in which the particles of the wave are spread out, and then you show an area in which the particles of the wave are close together. And that we can see in this slinky wave right now. So spread out here, and then close together there, and then spread out again. and the individual parts of the wave, of course, are moving back and forth in the same way that the wave is moving in that direction. And the scientific word for that is parallel. All right, so they're moving sort of in the same direction. They're moving parallel to each other. What kind of wave do you think sound is? Is sound a transverse or a longitudinal wave? I'm going to go ahead and play this video for you, and then you can take a guess. This is a speaker, and this is a representation of what is happening to the air in front of that speaker. Alright, so if you guess that sound is a longitudinal wave, you are correct, right? Because as you can see, there are areas in which the air is compressed together, alright, which is these areas, and then there are areas in which it is spread out, compressed, spread out, and compressed. So sound is an example of a longitudinal wave. And each of the individual air molecules or particles are going back and forth, forward and back, left and right, parallel to the direction in which the wave is propagating. All right, so sound is a longitudinal wave. Sound is a longitudinal wave. Speaking of sound, there's something else you should know about waves. You should know their medium. And like we talked about in the last video, the medium of a wave is the stuff, the material, or the matter that wave passes through. So, in the case of sound, the stuff that sound is passing through is air, right? So the medium of sound is air. And air isn't nothing. Air is made up of actual molecules. Right? Air is made up of actual molecules. And in places where there are no molecules, where there is no air, such as in space, you actually can't hear anything. So that's why you don't hear noise from the sun, for example, because the sun is this huge fireball where explosions, huge explosions are happening every day. And despite the fact that it's so far from us, these explosions are so loud that if there was air in space between the sun and our tiny little earth here, you actually would be able to hear the sun. But there's no air because space is a vacuum. Space is a vacuum. So no air in space, and so if you ever got stranded in space, it would be a very lonely, quiet place. There would be no music, and there would be no birds whistling. Other mediums of waves, all right? If you get, for example, an ocean wave, what do you think the medium of an ocean wave is? If you guessed water, you are very correct. So the ocean wave is moving through water. If you took a rope and created a transverse wave that looked like this, the medium of that wave would be the rope. Last example, how about earthquakes? What is the medium of an earthquake? What is the wave of an earthquake moving through? If you guessed the ground or the floor or rocks, then you are correct. All right? So the medium of an earthquake would be basically the surface of the earth.